examiners like to have all sorts of fun when it comes to using some basic concepts, but making you think a little bit outside of the box of them. So we're going to look at just the mean and the median today, and just talk about what happens when the question isn't just a straightforward calculate the mean, calculate the median. So this is the notation for the mean, which may be new to you, but this is a sort of universal notation, x bar or x hat. And it's, well, mathematically written exactly as you'd expect it to be. Add up all of your x values and divide by the number of values that there are. So this big squiggly thing, this is sum, this is capital sigma, but it does mean, add up, sum. Xi means each individual value in your list. So that would be, say in this list here, 5 plus 6 plus 10 plus 15 plus 24, each individual one. And then n is obviously the number of data sets, pieces that you've got. So 5 here, the number of pieces of data. So it's just a formalisation of what you've known for quite a long time now, I'd imagine. So to calculate the mean of this set of red numbers here, we would say, well, that is, x bar is 5 plus 6 plus 10 plus 15 plus 24, sum of all your individual values, divided by 5, the total number of values there, and that gives us a mean of 12. That's fairly straightforward, I hope. What happens when I add in another piece of data? Now this is where the exam boards, or even just in real life, you may well end up knowing what a new mean is and wanting to work out what your piece of data is. But let's just go into what would happen if I added a piece of data. Well, I'd recalculate a new mean. Probably bad to notate it the same way. Let's notate it slightly differently. Let's go x2. So this time I've got 5 plus 6 plus 10 plus 15 plus 24, now plus 30, and now I'm dividing by 6. I've got 6 pieces of data in my new set, and that gives me that the second mean is 15. So that adding 30 to my list has affected my mean. So what happens if they ask the question the other way around, and they say 5 numbers added together gave us a mean of 12, and 6 numbers added together gives us a mean of 15. Can you work out what this additional value was? Well, to do this, we'll need to use the formula that we've got here. So I know that x bar is the sum of all my x values added up together divided by my number of numbers. So if I know that x bar is 12 and my number of numbers is 5, then I should be able to say what the sum of all of my numbers added up was. So just popping your values into your formula, that gives us that 60 was the total sum. Now we know that because we went the long way round. We actually added up, and we did indeed get 60 over 5 over here. But imagine you didn't know any of this right hand side, you didn't know any of that. You could still get to what that total was. Similarly, we could do the same for the other set, so our new progression, what we know now. So 15, our mean, is equal to the sum of all the x values divided by the total number of pieces of data, which is now 6. Multiplying those two together, we will get 90. And now we can see that the two sums have a difference of 30, which we've got here. So using this formula and just rearranging it like pieces of algebra, just like an equation, which it is the way through these sorts of problems. What about if we're given a problem involving the median or the quartiles? Well, one thing they've done in the past is they've introduced unknown values and asked about what these values could be. So let's look at the median. What could the median be in this list? That should be an n, there we go. Well, the list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 pieces of data long. So Q2, which is the median, is n over 2. We've got 11 over 2, which is 5.5. And so we've got to round up to the 6th piece of data. Okay, so counting 1, 2, 3, 4, 5, 6. Oh no, it's a Y. Okay, well, to calculate the list, we know that it's an ordered list. So Y would not be there unless it was larger than 4 or equal to it and smaller than or equal to 6. So that is precisely what Y could be. Y is either 4, 5 or 6. Otherwise Y would move up. If it was bigger than 6, it would be the other side of this 6 here. If it was smaller than 4, it would be the other side. Now it could be equal to 4. You could have 4 and 4 in the next to each other in an ordered list. And likewise it could be 6. But that's it, that's all we've got. So I've got Y being the set of 4, 5 or 6. Those are the only options I've got. What about the values for X and Z? Well, by the same principles, we know that X could be 1, oh, no curly bracket there, 1 or 2. For the same reasons. If it's 1, it'll sit this side, that's absolutely fine. Same with 2. But if it was a 3, I'd move it to the other side of the 2. Z could be 9, could be 10, could be 11, and could be 12. Those are our only options. But again, we're just trying to think, what do we know? We know it's got to be an ordered list, and we know how to calculate the median, the lower quartile, the upper quartile. And it's just using those and having the confidence to use them even if it's got algebra involved. This is something we will be definitely revisiting in class, but just nice for you to see and have a think about now.